Then our next speaker, Nick, CEO of Fuel. Give him a round of applause, please.
I'll grab you the clicker.
Oh, it's right there. All right.
Some slippery stairs. All right, so I wanted to do a highly technical presentation describing every aspect of our register design, our memory, the way things work, the way calls work, the way fraud proving works, the way introspection works. But instead, I'm just going to tell you a story, and you can look that up later yourself, because I only have 7 minutes. So yeah, to start it off, if you guys can hear me okay. So the FuelVM, what the hell is this? Basically, for today's agenda, we'll just go over some more burning questions that I think a lot of people have about what our VM is and how we've designed it. Starting off with UTXOs, then going over to how we do smart contracts and UTXOs, because that's always a big question. P2SH and predicates, and then as well how Fuel is trying to design the foundation for a more modular world for blockchain. So to start it off, the EVM is great, but very convoluted and really complicated. So it was designed, unfortunately, very quickly. And I know because I was sort of like at the aftermath of when they did it, and it was very fast. And unfortunately, it came with a lot of interesting baggage. While it served its purpose and moved blockchain forward tremendously, like I think we all know, we could probably do something maybe a little more interesting and probably try something different. So, so with Fuel particularly, a big thing to kind of think about here is basically like the power of some of the Bitcoin transaction model, but with really the expressiveness and the flexibility of Ethereum. So that's basically how you could think about the FuelVM in and of itself. So fundamentally with UTXOs, it's a scary word, but really it's just to describe what we kind of consider as state access lists. So effectively just describing what areas of state you're touching in a virtual machine, and then basically describing how that's going to be changed. So like a typical model just has some inputs and some outputs, and basically each transaction is sort of defining a state transition, you could say. So just transitioning from the previous state where everyone had this to another state where everyone else had something else. So it's really quite simple. It's just the word, you kind of say it, and then you lose people. So to demystify it, it's really dumb and simple, and it's basically just this. So a really nice side effect and something that the FuelVM tries to do is reduce a lot of burden that we have with blockchain, which typically comes from state growth. So if you know anything about how Ethereum's designed and how a lot of blockchains are designed, the state can be immense and enormous. And effectively, and I'll show you in a second, this really constrains our ability to sustainably scale as a technology and as a group. So blockchains that use a UTXO model can benefit from some really nice properties. One is, if you know anything about blockchains, it doesn't need to have a global state root, but it can still be valid and still like client provable, which is a huge win if you're looking at how to build a blockchain. If you need to serialize every single state transition into a giant Merkle tree, it's really prohibitive, very expensive, and it's not great. So we remove that with a UTXO model, which is really cool. The second thing is UTXOs provide a state minimized alternative to smart contracts. So in RVM, we try to get developers to push away from using smart contracts, even though you have full, flexible Ethereum-style smart contracts. We try to give you more tools. And as well, each UTXO, when it's spent, only takes up a single state element. And again, it retains like client provability. So this is a very, very important factor with blockchain design, and it's something that unfortunately many blockchains succumb to. So state reduction is a big piece, but I'm not going to spend a lot of time on it here. Tomorrow at L2 Day, I'm going to talk about how we basically solve or reduce the state growth problem significantly using this technique. But anyway, that's one big benefit. And as you can see, Peter, the developer of Go Ethereum, really doesn't like state and talks about it all the time, and basically says that if we don't deal with these kinds of things, we don't find other ways to address it, we're going to see an existential issue with Ethereum at their current node requirements. So in addition, the Fuel virtual machine is also designed for parallel processing. So this is a really important feature of, I would say, any modern virtual machine. And you really want to be able to use all the power of your machine to process transactions. So in a sense, UTXOs enable us to do this because they act as a state access list. So this means that you can analyze a block and you can just say, okay, I know these transactions are going to touch these pieces, and thus we can process them on these threads, and they're not going to bother each other. So very important. Second thing is, not only can you process in parallel within a block, but you can process across blocks in parallel too. So you get really nice properties in terms of parallelism with using a state access model like UTXOs. So in terms of the results, and I know TPS is a horrible number and we should never really discuss it, but fuck it, everyone asked me for the TPS, so I'm going to give you the TPS. So basically, the way to think about this is per core right now on an unoptimized node that we have, we can verify about 7,000 transactions per second. On an 8-core, up to 58,000. And because of the way our model's designed and also the way that UTXOs work, we're able to get really nice compression properties, which will allow us to post about 2,500 TPS a second on Ethereum DA, given that we used all the DA on Ethereum. But effectively, that's what we can process at the limit. And so effectively large numbers, but again, TPS is a horrible metric, so don't ever use it unless you have to, unfortunately, just say it once. But anyway, there, I said it once. So in terms of another thing that's very, very important, so the FuelVM also brings something that I think is incredibly important to the design of blockchains in general, which is very rich light clients. So light client support allows just regular people to be able to validate and introspect different pieces of the chain. So with Fuel, we redesigned things like the block header and the transaction structure such that it's very easy to introspect everything that's going on within the system, such that even on-chain light clients are very approachable. They're very easy. It's really just verifying a few light Merkle proofs, so it's nothing too intense. And so when you do things from scratch and you rebuild, you get to address and fix a lot of these shortcomings that you typically see in these blockchain systems. So rich light clients allow for really great cross-chain introspection. So effectively, one rollup can really take a look at what's happening in another rollup. And this is very, very important if you want to have really nice properties of bridging between rollups. So a lot of the FuelVM design is designed to minimize state, and it's also designed to have really nice properties of introspection. So light data introspection is very important to us in terms of how this will work. And ultimately what this means is that bridging and doing trustless bridging with no multi-sigs and everything else is very, very approachable, even in the optimistic setting, without ZK, without anything complicated. It's just very easy to see what's going on all the time. Another thing that we focus on in our asset model in UTXOs is having multiple native assets. So with Ethereum, unfortunately, the only native asset is Ether, which is really, really constraining. Every other asset is at the application level, and this really constrains the kinds of designs that you can actually put together with with a blockchain. So in the FuelVM, all assets are, or can be, at the native level. And this allows for a really interesting property of settling lots of different kinds of transactions with lots of different assets and lots of different criteria for settlement. So everything coming off of exchanges really benefits from this because a lot of the time you just need to send asset here, send asset there. And that's a lot of what blockchain does. And so we really optimize for that in terms of our native model itself. And as well, this also means not only settling fungible tokens, but also NFTs. So this is another question we get all the time, which is UTXOs and smart contracts and how effectively this whole thing with Cardano really kind of skewed everyone's perspective quite a lot in terms of how this actually functions. But basically, a big thing that came up was Cardano designed this smart contract model that was really blocking in terms of how it was processed, and it ended up creating a horrible user experience, thus scarring UTXOs for the end of time for everyone else that actually doesn't have this issue. So if you ask, which was why I was particularly angry with Cardano people. Nothing against Cardano people. Just this was a bad design decision. Is it possible to have really nice Ethereum-style malleable state smart contracts in a VM? The answer is absolutely. And this is another funny one that I found too. But effectively, their scientists are working on it. Effectively, UTXO smart contracts are very possible. So you can see here the inputs act as a nice state access list. You have multiple inputs. One's a contract input, in this case how the FuelVM works. And then when you're basically defining the output, you're notating two things, the state and the receipt route. But the user doesn't do that, the block producer does that. And so that gives you that malleability while still having all of the niceties of a state access list like system, like Fuel. So yes, we can do Ethereum style smart contracts, and again, state is malleable, et cetera, et cetera. And it supports all the things that you like about doing EVM style smart contracts, but doing it in a way that, again, can be parallel processed, et cetera. So another nice thing that we brought over from the Bitcoin space is effectively a concept of spending conditions. And so pay to script hashes is something that Bitcoin had before because of its UTXO model. This effectively allows you to send assets to a script that's a spending condition. And with this, you basically are trading off using a smart contract in state for doing something more over bandwidth and just using something that's lighter. And in my presentation tomorrow, I'll go into why that actually fundamentally addresses huge issues of state growth and kind of blockchain I/O issues. But in this presentation, it's very good. It's very state minimized. The next thing is that this also acts as effective account abstraction. So with Fuel, you can sign at the native level with Solana wallet, with P256, with any kind of signing curve you want, and it's supported at the native level and fluently in a multi-actor transaction, which is very, very nice when you have lots of different people settling lots of different things. And the code for this is actually prunable, so it doesn't need to be stored. So again, it's very light on processing. And Fuel predicates are really our version of this pay to script hash idea. And so you have expressiveness, but we keep them basically atomic so that we can not only process the block in parallel, but we can process all of the predicates in parallel too. And so again, this powers everything. And it can not only do multi-sigs and native account abstraction, but it can actually also fundamentally do order books, which is very cool. So it's a nice side effect. So that will be the most state minimized possible order book you could ever construct. And again, each UTXO only takes up one state element. So in terms of improving on the existing blockchain stuff and moving it over into something more modern, Fuel really does the job. In terms of being kind of a foundational layer for blockchains and blockchain VMs, I know I've covered a lot of different things, but the main thing is that on the horizon, there's also a lot of stuff to look forward to. So native meta transactions, or in this case, like fee abstraction, so not having to be stuck with fees, but doing that in a very efficient way at the very lowest level will be very fundamental for Fuel. As well, things like ZK proving with UTXOs it's much better in the sense that on the ZK side of things, you really want things to be more atomic, and that way you can do more parallelism with ZK itself. So I'm sure like Bobbin and the Maiden team will give you a good rundown of why UTXOs are a great model for that. And as well, UTXOs are also fantastic for privacy properties and as well for settling from intents. So settling down from, you have a bunch of users, and they have a bunch of intents that they would like to eventually settle. The multi-asset model of the Fuel VM is very much like that. That's basically it. And again, I would say that, I could have talked about all the very detailed specifics of our VM and how it works in the word sizes and everything else, but I just wanted to cover more of the major stuff that people typically ask. And if you want to learn about how our register VM works or all this other stuff, just read the specs because it'll be a way better presentation than I can give in 7 minutes. So, all right, thank you. Thank you, everyone. Yeah.
All right. Do we have any questions? Questions? Okay.
Nope.
Very straightforward.
Yep.
Okay.
Oh.
Wait. Last minute entry.
Yeah, I was taking some notes while you were talking. So great presentation, Nick. Really quite impressed after we had a talk outside.
You did mention something about having native support for particular signatures. Is that what you said?
Yeah.
And then you mentioned some of the signatures in Solana. Can you talk a bit more about that?
Yeah, so in terms of different native signing support, you kind of don't want to burden the user with having to switch wallets or switch keys, and so you want to support whatever wallets they have. So most people in the room actually have a hardware wallet that they're carrying all the time, and it's their iPhone typically, or Android maybe. And they actually don't need another hardware wallet for a lot of different cases. So being able to support that signing type at the native level is very important if we wanted to get, say, the whole room to adopt a new piece of technology. So in a sense, you want to support the signing technology that people have, and that could be MetaMask, that could be like a Cosmos wallet, or it could be just a hardware wallet that they have in their pocket. Yeah.
Interesting, because we also talked about having sort of native app chains that settle on Fuel.
Yeah.
Right. Okay. Got it. Great.
Yeah.
Thanks.
Cool. Any other questions? Thoughts? Oh.
So for the pay-to-script hash opcode, do you also support different kinds of hashing functions in order to enable atomic swaps and the other things with a wide range of other layer 1 blockchains?
Yeah, 100%. So within the predicate itself, you can tap into pretty much anything in the VM that doesn't touch state. So the predicate tries to remain a stateless, effectively atomic script. So hashing, all that kind of execution is fully available. The FuelVM also has some very interesting properties of self-introspection. So in a predicate itself, you can actually take a look at the transaction itself, because it'll be put in memory for you. So these little things allow you to do really cool stuff. So you can introspect your own transaction, look at the inputs, look at any aspect of it, hash, verify, Merkle proof, whatever, and then that becomes your spending condition. So effectively, it's providing the developer more ways to do things that are outside of the context of smart contracts. Because again, you can do everything with smart contracts, but as some of the devs in the room probably know, it's absolutely horrible to try to jam everything through smart contract transactions. Like, it basically ruins all forms of scalability. So yeah, that's kind of the idea. So 100%. Yeah. Yeah.
I have a follow-up question. I think there's a lot of talk currently. There's like EAP 7212, I believe, which essentially talks about using SCCP's 256R1, which is commonly used for biometrics and enclaves.
Yeah.
And I was wondering if you're looking to support that now that the industry is kind of...
I'm actually demoing that tomorrow.
Ooh,
yeah.
Okay, nice.
So, and we've supported that for a few months already. We just didn't write the WebAuthn script. So I spent the last few days writing that, and it was absolute hell. But we've got it running, got it verifying. Yeah. Woo!
That's critical for onboarding, in case you could essentially create a wallet using biometrics, and the user doesn't have to be exposed to their private keys.
Yeah, so that you'll have with full native support, and it'll also be tooled in our SDKs too.
That's huge.
Yeah.
Last context. This is pretty cool because currently in the Ethereum world, people are talking about implementing SCP-256R1 on a layer 2 and then putting it on a layer 1. So while they're supporting it natively here. Cool.
Yeah.
Thanks.
Yeah.
All right.
All right.
Cool.
Thank you, Nick.
All right, thanks everyone.
Thank you so much.
Couple of steps, right?